I'm making this video for my friend who's struggling with our maths homework about completing the square. So if your name isn't Ethan, or you don't do A-level maths, or you already understand completing the square, then feel free to stop watching now. Although by all means do stick around if you want to, I would love the extra views. Before we can discuss completing the square, we need to understand that an equation such as this one, in the form y equals ax squared plus bx plus c, will give you a u or an n-shaped curve. Now, with all the equations in this form that we were asked about at GCSE maths, there would be two roots, i.e. 2 points where that u or n-shaped curve would cross the x-axis. And when the curve does that, it's always possible to factorise the equation, i.e. turn it into a pair of double brackets. Or it would be possible to solve it using the quadratic formula. However, in completing the square questions, they may give you an equation whose curve doesn't touch the x-axis twice, in which case you can't solve it by factorising or using the quadratic formula. An example of this kind of equation is the one I just wrote down. Y equals x squared plus 6x plus 11. Now, the first step to completing the square is we have to make a bracket of x plus half of the b coefficient, and then we have to square that bracket. For example, this, which I'm hoping you'll be able to read. Y equals x plus 3 squared. Then, on the same line of the equation, we need to put that same number again, so half of the b coefficient, in this case 3, into a bracket, square that bracket, and take it away from the first bracket we have. So, for example, plus 3 squared, which we're taking away from x plus 3 squared. Then we have to add the c constant onto the end, so plus 11. So the second line of our equation is x plus 3 in a bracket squared minus plus 3 in a bracket squared plus 11. As you can see in the next line of the equation, we do the working out that plus 3 squared makes 9. So minus brackets plus 3 squared will be minus 9. After this, we can take away the 9 from the plus 11, and we end up with x plus 3 squared plus 2. Since we now know that y equals, in brackets, x plus 3 squared plus 2, we can work out the minimum point of the u-shaped curve it will make on the graph. How do we do this? Well, we know that whenever this bracket is 0, y must be plus 2. So how do we work out when x plus 3 squared would be 0? Well, x plus 3 squared would be 0 whenever x plus 3 is 0, because 0 squared will still be 0. X plus 3 will be 0 when x is minus 3. Therefore, we know that when x equals minus 3, y must be 2. And that is the minimum point of the u-shaped curve. However, in order to be able to draw the u-shaped curve properly, we also need to know the y-intercept. That's the point where the curve crosses the y-axis. So how do we work out the y-intercept? The y-intercept must be 11, the c constant from the original equation. We now know the minimum point of the curve and the y-intercept, so we can draw a rough sketch of the u-shaped curve for the equation y equals x squared plus 6x plus 11. I'll be honest and say this isn't a very good curve. It's not quite symmetrical, but if you can do a slightly better curve than I can, you'll be getting all the marks for completing the square. I'd like to move on to the more difficult part of the homework, which is what my friend was struggling with. When you have a coefficient of x squared. For example, y equals 2x squared minus 12x plus 7. This is similar to the equations we had before, but you'll notice that the a constant is now 2 rather than 1, which makes it a bit more difficult. The first step is to take the coefficient of x out of the equation as a factor, and then we leave the rest of the equation in some square brackets. This means we divide every part of the original equation by 2, So 2x squared becomes x squared inside the square bracket, minus 12x becomes minus 6x inside the square bracket, and plus 7 becomes plus 7 over 2. We write that as a fraction rather than as a decimal because it can make it easier to turn it into a whole number again later on. You'll see what I mean. As you can see, after taking the 2 out of the equation as a factor, we simply continue as we would anyway inside the square brackets. We can effectively ignore the 2 for now. So once again, we do the x minus half b in a bracket and then square it, and we take away half of b squared in a bracket, and then we add the c constant once again. So in this case, 2, and then inside the square brackets, x minus 3 squared minus 3 squared plus 7 over 2. As you can see, in the next step, we once again simplify the half b inside the bracket squared, and it comes out as minus 9. The next step is different to before though. We have to get rid of the square brackets, and we do that by timesing everything inside the square brackets by the factor that's outside of them. What this means is we times the first bracket by 2 to get 2 brackets x minus 3 squared. We then times the minus 9 by 2 to get minus 18, and we times the plus 7 over 2 by 2 to get plus 7. That's why we didn't turn it into a decimal before. It's far easier to get rid of the denominator in the fraction than it is to multiply a decimal. In a final step, we add the 2 constants together to get minus 11. So the final equation is y equals 2x minus 3 squared minus 11. The final step is quite similar to the examples we did before. You simply work out that when x equals plus 3, y must equal minus 11. Therefore, you can plot that as the minimum point of the U-shaped curve. You also know the y-intercept already, because that is simply the c constant from the original equation. So in this case, plus 7. Therefore, the final step is simply to sketch your U-shaped curve. And voila! I once again encourage you to try and do it better than I can. There's one final aspect of this topic I need to discuss today, and that's when you have a negative coefficient of x squared, in this case minus 1. The solution to this is quite similar to the example before when we had a coefficient of plus 2. You simply take it out of the equation as a factor, and then use square brackets around the rest of the equation. However, you need to be careful with the signs, because like with the 2 before, we need to divide everything in the brackets by the factor we're taking out, which means the signs plus and minus swap over inside the square brackets. So the minus 2x becomes a plus 2x, and the plus 7 becomes a minus 7. Like in the last example, we then carry on solving the equation inside the square brackets as normal. We then get rid of the square brackets by multiplying everything inside by the factor we took out, so minus 1, and all that does is cause all the signs to change again. So we're left with minus 1 around the brackets x plus 2 squared, and then plus 8. The final step, drawing the curve, is again quite similar to our previous examples. However, you'll notice that in this case there is a maximum point of the curve rather than a minimum one. This is because the coefficient of x squared in the original equation was a minus, which means the curve is going to be an N shape rather than a U shape. So this time, when we work out that when x equals minus 1, y must equal 8, we're actually working out the maximum point, the top of the N curve, rather than the bottom of the U curve. You'll also notice that the y-intercept, 7, again based on the original equation down at the bottom, is lower than in y value than the maximum point. This means that when we draw the curve, we should get a nice smooth N-shaped curve rather than a U shape. And that is completing the square, explained quite badly by me. Please do talk to our actual maths teacher if you still don't get it.